Okay, back again for part two. So now we're going to be multiplying in complex form. So we can do this two ways. We can do this in standard form, which let's do that first, and then we're going to do it in polar form because we've got those tricks that we can use. So if we did this in complex form, we would just FOIL. So if we FOIL this out, you would get negative 5 plus 5i. So make sure you do the math. You get a negative 3, and then you get minus I plus 6i minus 2. Combine your negative I plus 6i to get 5i, and your negative 3 to negative 2 to get negative 5. Okay, so here we go, negative 5 plus 5i. From here, we can do exactly what we did in adding and subtracting. We could find your modulus from this. We could find your argument, put them together, bam, polar form, okay? But what I want us to look at is what happens if we found the argument of the first binomial. Okay, so if we did that, we're going to take the square root. I don't really have a lot of room here, so I'm going to do the best I can. So you would take the square root of negative 1 squared plus 2 squared. So that's going to give us the square root of 5. 4 plus 1 is 5. So we get square root of 5, CIS, and then we find the modulus, or the argument. So it's inverse tan of 2 over negative 1. So let's figure out what that is. 2 divided by negative 1. And I got negative 63.4. So let's just say negative 63. So at this point, that's going to be in the second quadrant. So that means I need to add 180 to this, and I'm going to get, well, what did I say, 63? So I need to say 180 minus 63. So I got 117. Okay, so when I got that, now I need to do the exact same thing to this one. So I'm going to do square root of 3 squared plus 1 squared, and I'm going to get 9 plus 1, which is going to be square root of 10. CIS, put this in parentheses, and then I got to find my tangent. So I get 1 over 3, so inverse tan of 1/3 is going to give me 18.4 degrees. So I am in quadrant 1, so that means I don't have to add anything. It is what it says it is, so 18 degrees. So now, remember we talked about this yesterday, today. So at this point, because they're being multiplied, we can multiply these two moduli together. So if we do that, we get 5 times 10, which is going to give us square root of 50. I want to make room. So square root of 50, CIS, and then we said we can take our degrees and we can add them together. And we proved this yesterday in our notes. So we get 135. Not a highlighter, 135. So the only thing that we need to do is take the square root of 50 and simplify the radical. So there's a perfect square of 25 in there. Square root of 25 is 5. So we have 5 square root of 2, CIS 135. And I just wanted to show you how you can do that, because a lot of times, and you might see this on your quiz on Thursday, that you're given these two polar forms and then you have to simplify them. So you have to realize that you have to take your moduli, multiply them together. So your modulus, your two modulus, multiply them together. And then you have to add your 2 degrees together. And then you're done. Okay, so now we're in standard form for division. And I am not a fan of going, because when you were up here, you could FOIL these really easily and then get your complex number, your rectangular form, and then you could convert that easily to polar form. Here, though, it's a little bit more difficult because you have to do your conjugate. So you would have to do this and multiply it out. So you'd have to FOIL down here and you'd have to FOIL up here. And remember, what's awesome about a conjugate is it gets rid of your inside ones. So you really just have to multiply your FOIL, your first times your last. So on this one, we would get 9 minus I squared. Don't forget what that means. It means it's a -1. So then it's really saying +1. So you get 10 in your numerator. And then you would have to FOIL the top and then combine like terms. But when I did this earlier, I got -1 plus 7i. So you could do that on your own if you want to. And then from here, you would have to change this into polar form. So it's just a little bit harder that way. You would just need to split this up. So this would be your real, and then this would be your imaginary. And so then you can go from there to find your rectangular form, your polar form. This is rectangular, so you could make that into polar form. Okay, so the other way that you can do this is take each one and change it into polar form individually, where we're going to get really good at changing these quickly. And we already did it in this top one. Do you see they're the same? Same. So we know that we have square root of 5 CIS 117 divided by this one is our denominator, and it's the same as this one. So it was square root 10 CIS of 18 degrees. Now remember, we said when we have this, we simplify or divide the arguments here. So if we had this, let me change back. So because we have 2 square roots, we could put them under 1 square root. So then what do we get? Well, we get square root of 1/2. And you can rationalize that denominator if you want to, but there's just no point in doing that at this point because we're just going to stick it in the calculator. So what would we do right here? We said we would subtract those. So if you subtract 117 minus 18, you get 99. So here's the only trick to this. You have to, when you're subtracting, and let's say it was the other way around. Let's say it was 18 minus 117. Well, you would get a negative. And so if we got a negative number, we would have to add 360 to that to make sure that it was in our 0 to 360 circle. But if we had to add 2 numbers together and they gave us more than 360, then that means we've gone around the circle and then gone a little bit more. So that means we would just have to subtract 360. And if that's confusing, stop by and I'll explain that more in detail. So now that we're here with our 1/2 CIS, or square root of 1/2 CIS 99, 1/2. Oh, there it is. So the square root of 1/2 is equal to 0.71. So we are 0.71 CIS of 99, and that is our polar form. Okay, sorry about that. I got myself in this circle, and then I wanted to go put it back in rectangular form, and that's not what we're trying to do. We're trying to put it into polar form. So we're done. All right, let's keep going. So it says plot the number in complex planes. Remember, here's your real. Here's your imaginary axis. So this means I'm going to go -3 on my real, and then I'm going to go down -3 on my y, my imaginary, and I get a point right there. So if they wanted you to draw it as a vector, it'd be like this, or if it's just a dot, like it just says to plot it, it's just a dot. Easy. Okay, next, find the modulus value of the complex numbers. So we just do the square root of our real, which there we don't have a real, so that's 0 squared, plus 15 squared, which is going to give us square root of 15 squared, so then that's just 15. Okay, I don't want to write in pink. Okay, so now over here, we do the same thing. So -7 squared plus -3 squared. And that's going to give us 49 plus 9, which gives us a square root of 58. Let's see if there's any perfect squares in there. So far, no. No, I do not believe there is. So we are done. Okay, next, write the complex number in polar form. Express the argument in degrees. So on here, we, in polar form. Okay, so that means we're going to need our CSI. So we're going to need our modulus, CIS, and our argument. Okay, I'm going to stop again because I'm almost at that 15-minute mark, and I'll finish this in part 3.